great pleasure to introduce you to Vance Bergeron, Research Director at CNRS at the Physics Lab. He's the founder and the director of the ANTS Association that provides patients with state-of-the-art rehabilitation tools and also organizes recreational therapies.
Great, thank you, very much. Today I will be speaking about functional electrical stimulation, and more specifically cycling with functional electrical stimulation, which I feel is an electrifying sport, as you can see. The first photo is one that's near and dear to me because it is a photo of the very first heat of the very first race in the Cyclothon. So we were the very first ones to be able to race and go. And at this moment, I was in the lead, but they didn't end this as friendly for me. What's interesting also about this photo is it shows someone who's in a tricycle, myself, in what they call a tadpole, which means there's two wheels in the front, one wheel in the back, opposed to a delta, one wheel in the front, two wheels in the back. It's a detail, but it's a tricycle. And the other gentleman behind me, Japanese, he's in a wheelchair, but he's working his legs to move the wheelchair. And so I find that interesting too, because the photo does show the differences in the different types of machines that can be used. However, if we go back in history, we will find a gentleman whose name is Gerard Petrovsky, who envisioned both types of exercise in the 1980s. I show you his picture. I also show you on the right-hand side pictures of his laboratory with the devices. They're stationary devices on the right, and the wheelchair device on the left. So as you can see, 82 was a long time ago. This was thought of, this is not new, but it hasn't been very publicized. The Cyclothon is something that's brought a new light to this, and I'm very happy that they've been able to do that. And so it's an interesting way of bringing technology, handicapped people, and the public together. How does it work? Well, I borrow this schematic, which is a movie clip, which I will show from Kenneth Hunt, who is one of the experts in the field, if not the expert. And I borrow his pictures, his automation, where you find someone in a tricycle like mine, and normally you would send messages from your brain, go through your spinal cord, they would arrive at your muscles, your quadriceps here, push the pedals, and then motion would come from the push on the pedals to the bicycle. However, the problem is, if you have a spinal cord injury, you no longer have that connection. You must rely on an external source, the boxes you see at the back of the bike, which then replace the signal and activate the nerves in exactly the same way that your own intention would when you had voluntary notion. So it's quite simple in principle. It's just a matter of putting electrodes, these are not implanted, they can be, but they're not implanted in this case, strapped over a muscle, and then telling the muscle when it should activate. And it's simple but complicated. Now, to give you some information on the complications, I show you this. This is probably, these stimulation patterns are what we live by in this world. Because when you activate the muscle, determines the efficiency of the process. So you see in colors the three different main muscle groups that we activate. The red is the quadriceps, the blue is the hamstrings, and the green is the buttocks. These colors correspond to the circle here, which corresponds to where the pedal is located, the degrees. So 90 degrees is the pedal straight up, and as it goes around, all the way around the 360, you have an angle correspondence. Where you see shaded is the angles that correspond to what you would do to stimulate the right quadriceps on the top, and when you would do it and when you would stop doing it, so that you're pushing only, not pulling at the wrong or right time. So this stimulation pattern is actually unique for each pilot. because of the physiological constraints that are on the system. So we live by these patterns. They determine the efficiency and the ultimate speed at which we can go. What makes things more complicated is off to the right, which is cut a bit, but you see that the pattern has been shifted. This is for the same person, but now he's turning at 50 RPMs. So we have to send the signal a little bit sooner, because by the time the signal reaches his leg, he'll be already in another position. So you're seeing a result of the time lag in the signal processing that we have to compensate for. So what we do, at different RPMs, we send the signal at different times so that you get maximum torque so that you can pedal with the most efficient way. So it gets a little tricky, and one has to take care of that notion. It's one of the reasons that limits some of the performance on these systems. Another limit, is fatigue. When we use this electrical stimulation, we don't activate the fibers in the same way as we physiologically would. Off to the left-hand side, by the way, this is a photo taken directly out of Anil's thesis. And on the left-hand side, what you see is small and large bundles in a nerve bundle. The dark corresponds to activation. The light corresponds to no activation. In the beginning, when we want to move the muscle physiologically, we start to invoke more and more bundles, parts of the bundle, and we eventually lead to, when we want to go rapid, activating the larger ones, which are the fast twitch muscles, to go faster. That's the physiological process. However, the problem is when we electrically stimulate, we do the inverse because of the resistance. Lower resistance in the larger bundles allows the electricity to flow better in those, and so we go to those first instead of last. And so as we increase the voltage on the stimulator, we'll increase not only the slow twitch, but the fast twitch also, all at the same time in the beginning. What this means is the muscle will fatigue very, very shortly. There are strategies that are being approached, and one of which is, instead of using a large electrode, we use several small electrodes. And we don't stimulate the entire muscle at one time. We stimulate different areas of the muscle, and perhaps at different frequencies also, to invoke differences so that the muscle does not fatigue. Parts of the muscles are resting while other parts are working, which is more similar to the physiological processes that we see. And with that, you can increase the fatigue factor by about 30%. This was a major finding in Kenneth Hunt's and Neil's thesis work. So that's where we are at now, and it allows you to understand some of the complications in the process that we have to deal with. Now, I would like to also share other elements of cycling electrostimulation. That is the availability of these types of devices. Where do you get them? Well, usually we make them. The reason is because commercially available bicycles are few and far between. What you see on the left-hand side is the very first commercial bike that was developed out of Glasgow University with collaboration at Max Planck from Hasumed as the industrial partner, which is called the Ria bike. It no longer exists. It did exist for a few years, but it was not profitable because what happens is the amount of watts that one can produce with this is very low. It's very inefficient. And so when you want to take it outside to ride it, you're not able to do much. You can't go up hills, you can't go very fast, and so it's not very advantageous. That does not mean that electrostimulation is not advantageous. It just means that this bike's performance wasn't to measure. I show on the right-hand side, and again, I apologize for this slide being clipped, but you see the essentials of what I call a hybrid cycle. This is a cycle that has both legs and arm propulsion. Why? Because with the arm propulsion, you have additional watts. So Rick Berkelman, and this is called the Burko Bike after him, invented this, and here's the patent number. The year was in 1980 something, I believe, also. So it's been a while. But Rick invented this so that people who are handicapped like myself but have arm strength can actually do the electrostimulation. At the same time, they're doing the arms, which gives enough power to actually accelerate the bicycle in different environments. In addition, Rick works with people on an individual basis, puts electrical motors into the bicycle also to have even a more of a boost in case that's not enough. And in fact, I worked with Rick on my Burko Bike to have a voice control to change the gears. And we used a lethargic voice control so that we did not have parasite noise, and we had electronic gears so that I did not have to take my hands off of the handlebar. So it became much more convenient to change gears and change the stimulation patterns as I ride the bike. So these bikes do exist, but they're far and few between, and more often than not, they're homemade. But there are many industrial versions of this stationary electrical stimulation, which I show here. The very first one is no longer being manufactured. It was in the 90s. I show it at the top, and it's basically a stationary bicycle. It works exactly the same way that I showed you before. It's just that it's stationary. There's a resistance, which is not coming from the road. It's coming from the electronics or the motor that it's inside of it. And you see the very first one was used very successfully. The problems with it were, the main problem is that you have to transfer to get onto it. You'd have to get off of your wheelchair to get into it. Newer versions, and all of these are on the market today. I'm familiar with each one of them, and I can tell you that each one of them are made professionally on a very good equipment. They have the advantage of you can use them in your wheelchair. You just ride up to the system, you get attached to it, you attach the electrodes, and then you're off and going. And one of the most important things here is the fact that you're building the muscle, and that helps to protect your body. Because when we're set in long times in wheelchair, we can have problems with pressure sores. But if you have muscle to protect your skin and protect it from the bones, you will be able to protect yourself. So there's immediate advantages by doing this. We try to make it interesting by putting a screen and having some animation. That gets better and better as we go on. And in the future, you will see virtual reality systems coming out. There are some professional bicycles that have these virtual reality systems already. And we have incorporated those in our devices here in the lab. So what makes for a lot more fun when you're riding these. All you need is a fan then to make it feel like the wind's coming by. And that works pretty well too. So that's how the state of how it works, what's available, and why we use it. What I'd like to do now is turn to another point that I would like to make. It's sort of the precursor to the Cyclothon. This was thought of by Nick Donaldson and Kenneth Hunt, and it was in the 2005, what they called the university's Sports Day. And here what you see are several paraplegic and tetraplegic riders. Most of them, I think if not all of them, are on tadpole tricycles, home built at the schools, and they're playing a game familiar to a soccer game where they have a pillow that they would each run or use their bikes to throw between the two pillars there in yellow on the other end. And they worked as teams together. So that was an interesting application, I thought. It was a motivation. And motivation is one of the most important pieces of keeping someone involved in a sports activity. And I salute them for doing this. They continued with this 2 other times, once in 2006 and the other time in 2009. And I show you here a photo from one of those sports days where they were racing. So this was the first races against each other. There's 1, 2, 3, 4, 5 people here. There was 11 competitors total. They had 2 types of races, 100 meters and 1 kilometer. The performances are shown here, 29, the raw data, 29 seconds to 86 seconds, which translates to 11 or 12.4 kilometers to 4.2 kilometers per hour on an average, okay? And then there was the 1 kilometer race, which was a bit longer, of course. Now the numbers have been cut, but it's 11 and 2.5, which you don't see on the slide, but they're slightly lower. That lowering is due to the fatigue. It was a longer race, so the average speed was slower. But you're in the 11 to 12.5 range, as you can see. And what we know is that can be improved, and we saw that in the Cyclothon, the very first Cyclothon in 2016. Here you're looking at the podium for the 2016 Cyclothon. You see that the average speeds for the best heats are shown below, where you see the winner at 15.4 kilometers per hour. This was a 750 meter race, okay? So there was some fatigue factor going in, but it wasn't quite a kilometer, but it was close to that. The difference here between these 3 gentlemen are the one who won was actually implanted electrodes. It was the only rider with implanted electrodes, and he was paraplegic. So he had his respiratory system also. The interesting thing is that the other 2 individuals were tetraplegics. So they don't have the same respiratory capabilities. That's one point. And the other point is they used external electrodes, which are less efficient. But it is quite surprising that you're reaching the 11 kilometers an hour, very close to the 15 kilometer per hour mark. Close, but yet not close enough and far. So our objective is to break that barrier. And to break that barrier, we hope will happen in the next Cyclothon. But we've been doing this in Lyon, and here you see a photo of our second Lyon Cyber Bike Day. This is an outdoor photo where we were racing 500 meters. Unfortunately, this has been cut. I have a partner in this, which is the Lyon Free Bike, who helped us organize the race. And you're seeing competitors from Holland in the blue. So it was an international endeavor, which makes it a lot of fun. The speeds that were done by the 4 competitors were 11.2 and 17.1. So we did overcome the 15 kilometer per hour level, but of course it was only 500 meters, and one must ask the question if the 250 meters extra would have made the difference there. I don't know.
About the electrode? Was it implanted electrode?
No, these were all surface electrodes, and one paraplegic and 3 tetraplegics, myself being one of them, the slowest. So what I will conclude with is an objective. And the objective is for this year's Cyclothon, 2020, which will be held the 13th and 14th of November. So I invite everyone to tune in, basically, because it will be done on a virtual basis this year because of the COVID, which is very unfortunate. But they're doing a very good job of collecting everyone together and organizing, as you can imagine, this wonderful event. And when we look at the FES racing, what we will be looking for is an average speed of greater than 20 kilometers per hour. So I will leave you with that objective and any questions that you might have on functional electrical stimulation. And I thank you for listening to this talk.
You had the idea of having voice control for gears. What about brakes?
I did not do that for the brakes. I did use because it was so easy to have a back pull for the brakes.
Oh.
So I used the old version. When you were a kid, you probably had a bicycle which was a fixed gear, and you could just pedal backwards and that would brake. And so it was very easy to have a braking system to just pull down. So you're going forward. When you want to brake, you just do this. And it's very quick, and so there's no time delays, because braking is a very important thing to do. So no, we don't use the voice control because of the non-reliability and the time scale that it would take, and it's such a critical thing to be able to brake.
I was wondering, once you have the arm plus the leg, then you don't have any more dead zone in the pedaling cycle, right?
It helps get over the dead zone. That's an additional benefit from having either a motor or having an arm thing. So there's no issues with the dead zone. Additionally, you don't have to be as precise on the stimulation pattern. When you're not using anything else, you must be very precise on the stimulation pattern. Otherwise, you will be put into a dead zone. What he's talking about, the dead zone, is when the pedal is from top dead center to here. Now, it's a dead zone because you have to change your quadriceps from pushing, you have to change your leg motion from pushing to pulling, both of them at the same time. And that change, you need enough momentum to get over that during the transition. So this is a difficulty. We call it the dead zone. And if you have your stimulation parameters correct, you can do this. But if you don't, you can lock and you can actually go backwards. So it can be very bad if you don't take that into consideration.
So will it be, for the competition, what will be the surface?
Yeah, the surface this year will not exist, which is unfortunate. It'll be done in a home trainer. So they'll use a home trainer, so everyone will have the same home trainer, and then everyone will compete against themselves with the same resistance. So, which is unfortunate, but it's the compromise that had to be done in order for everyone to do it. Otherwise, there was a standard type of surface that was in the gymnasium or the auditorium that we were in that was standardized for the ride. It was a bit rough. It wasn't a smooth surface, but it did simulate a road, a rough road, basically. I will also let you know that sitting in the back of the room is the bronze medalist, Julien Geoffroy, who has won that medal with the Swiss team, but trained here in Lyon. So we claim the medal also.
Yeah, I didn't know that Canada did organize APS races in 2005.
Isn't that amazing? Yeah.
It's amazing that we didn't know.
Yes, well, I did.
When did you find out?
I knew a long time ago.
You never told me.
No. I have to keep some things from you. Keeps you on your toes.
And so how can we attend? I mean, everything will be online now?
Everything will be online this year. Yes, exactly.
Yeah, it will be totally remote. Like
Right.
each team will just compete at home.
And you can just Google Cyclathon. You get onto their site and you'll see all the instructions. It's actually free. Well, that's one of the benefits because you don't have to pay to go see it, which was not the case before. But it is free and everyone can participate. I encourage it, not only for the FES cycling, but also for the exoskeleton race, the prosthetic arm, the prosthetic leg. There's a wheelchair race. And so there's quite a bit going on here with regards to what we spoke about today. And the BCI, that's correct. I thank you for reminding me. There is a BCI, brain-computer interface race, where there's an avatar that is controlled by thinking. So it's like Mario Kart, and you drive around letting him turn right, left, speed up, speed down by thinking about it, the motions. Which is the gaming that Perrine was talking about. So it's the direct, it's one of the few applications that BCI where you can have fun with, I believe.
A funny anecdote about that. Last year at the brain-computer interface conference, there was a pre-selection for the Cybertron with the BCI. And the funny part is that the researcher discovered at this moment how difficult it was to travel for people with disability. Each travel was an adventure with a failure everywhere.
Exactly.
You could make a BCI, but not the travel.
The other thing that we discovered in the first Cyclathon, because we were in the competition for the BCI, which was too much for us because it's really an expert's business, but we discovered that parasitic signals were a problem. These measurements are so sensitive that parasitic signals coming from other electronics near you can influence the machine. So one should probably take place in a Faraday cage if you want to make sure that everything's fine. But,
just to make them look demons or something.
yes, it would look very devilish that way too, I think. Yeah. Wow. Sort of it's a Star Wars type thing in a round spherical one. I like that.
We've reached the end of,
Yeah. So is there any other questions? I can close the conference, or I can still continue to answer questions. I want to thank everyone for coming. It's been a delight. We've filmed this. We will be putting it on YouTube in a professional way, so that you will have access. If you've missed anything, if you want to come back to anything. I know that it was all in English, or most of it was in English, so it might take a second view to understand some things, but you'll have that opportunity very, very shortly on YouTube. So I would like to thank also Amin particularly, because he did all the hard work. He did the heavy lifting, putting all this together. I watched. Yes. Thanks, Amin.